Alright, so there's been a request for some help with lab, so I'm going to talk you through some of the pieces of the torque lab. A couple pieces that are important right here. This equation is going to be important. You've got the clockwise torques and the counterclockwise torques. All the torque due to the masses hanging on one side of the pivot, and then all the torques due to the masses hanging on the other side of the pivot. That's how you're going to get your clockwise and counterclockwise torques. And when the lab's asking you for percent difference, you're going to compare those two. All right, so for the first setup, this is what it's going to look like. That top picture there, you're going to try to find the lever arm for the mass 2 so that the meter stick is balanced. And then you're going to add, for the second part of it, you're going to add a third mass so that the meter stick is balanced for 2 masses on one side, 1 on the other. And I will show you how you're going to try that out. So that's kind of the setup. First one's real simple, one on one side of the pivot, the other on the other side. Make adjustments until you get the spot, and then you're going to add that third mass in for the other one. So you've got this virtual equilibrium student use. And so this is for part A up here, part A, and you're going to do case 1, and everything should be locked except for what's highlighted. X1 is sitting at 20 centimeters, and that's the 20 centimeter mark. So it's 30 centimeters from the pivot point. So you've got to remember that. This is just where it's placed, not the lever arm. So when you look down here, you see these other tabs at the bottom, case A1, and so this is how it's set up right now. Go back here. We want to change this to, I think it might be at the 75 centimeter mark. So when I change that number, it changes the pretend meter stick. And you just keep trying it until you get it balanced. And so you can see it's kind of a trial and error piece. Then once you get that, you'll record the number. For the second case, you've got X1 at the 15 centimeter mark, and then your second mass at the 75 centimeter mark. And you're going to put that third mass somewhere. And so the way it is right now, one is at the 77 centimeter mark, and the other two kind of looks like this. So that's probably not going to work, so you might try something on the other side. So maybe I'm going to decide that I want to put it at the 25 centimeter mark. And now we'll check and see what it looks like. That's a little better. Just keep in mind my data is a little different than yours, but it'll be along those same lines. All right, so that's the first setup. Once you get your data here, you're going to open up your torque lab, and you've got the lever, first lever arm, second lever arm, calculate the torques. Find the percent difference between the two. This one, first lever arm, second lever arm, third lever arm. Remember, it's always measured from the pivot point to the place where the mass is hung, not the marker on the meter stick. All right, so part B. So part B is a little different. We have M1 hanging at 0 and nothing hanging on the other side. So it's all about the mass of the meter stick balancing the other side. And so what you're gonna find is you've got this M1 hanging 2/3-ish of the meter stick hanging on the other side. So that's 2/3 of the meter stick's mass and 2/3 of the length, and then 1/3 of the meter stick's mass on the other side, and then kind of halfway in between the pivot and the end point. So you've got to find the pivot for this. So go back to the virtual equilibrium, and it's sitting at, I think it starts off sitting at 50. So here's case B. So it is not balanced very well. And so we may want to shorten the smaller end. So maybe put it at 35. Check it, much better. So you see you can keep playing with it. So now if we figure out it's somewhere around that 35, so that's our x0, those are the masses. You're going to go back to the torque, so there's all your masses, and then you're going to figure out what all those different lever arms are. For R2, it's going to be halfway from the pivot to the 100 centimeter mark, so you'll figure out what that is. R1 is just the N0 to where the pivot point is. So that's pretty straightforward. And then R3 is halfway. So there's not really real masses hanging there. You're just using the mass of the meter stick because the meter stick has mass. So you've got to take that into account. When it's balanced in the center, we could ignore it because the center of mass is right at the pivot point. But when it's not, you can't ignore it. And part C, we're going to make it more complicated by hanging some unknown mass off the end and then trying to figure out where the center of mass is without any additional mass. So you're going to find that spot. And then, first thing you're going to do is balance the loaded meter stick. And so that's going to be case C, no M1. And so I tried somewhere around 40, and it looks like it balances pretty well. But you're going to really want to work on it, get it as straight across as you can. You might consider zooming it because you can see that it's not quite balanced, but you can, I'm just playing, so there we go. So let's say it's at 40. But then we need to figure out where you would put it for M1. We're going to hang M1 at 95, so somewhere between 90 and 100. You can change it if you want. You want 92, that's great. And then find the new pivot point. Balance it all out, and that's going to be B. And then go to your torque report here. X and L are going to give you the lever arms. So the weight of the loaded ruler acts at point C, so that's where the loaded ruler is center of mass, and that is X from the pivot point. The lever arm is the distance between the center, or where the pivot is, and where the mass is hung, that M1 is hung. So I'll go back to the picture real quick and show you that. That one right there. So over here, BL, and this is going to be your new center of mass here. And then that's going to be your lever arm for your meter stick. It's a lot. I hope that helps a little bit. Good luck. Bye-bye.